Hey guys, this is Miss Mo. This is our last section, 14.1, tessellations. Tessellations are like what you see on the bottom of your bathroom floor or the bottom of a kitchen floor when you have different colored tiles and they all fit together. That's called a tessellation. Okay, but we'll get to that. Okay, first we need to talk about transformations, or taking an original figure and changing it somehow. Okay, and the original figure, we call it the pre-image. The image is the aftermath. So the original is what you start with, and that's called a pre-image. Then, after you apply your transformation, or you apply the changes, you end with the image. Yeah. Okay? And it says the difference between them is one of them has little tick marks in the air. Yeah. And it says the thing with the little tick marks, that's called prime notation. It just means we put a 1 in the air. Yeah. Alright, but anyway, these little letters with the tick mark mean that they are the image. So this image has those little tick marks up in the air. It's called A prime or B prime. Okay, so the original is the regular letters A and B. The ending or the output is the thing with the tick marks. Alright, let's look at this first example. It says type the coordinates of the images with the little tick marks. So that means we want what we end with. It says type the coordinates of the images, as in where we end up. Okay, for each of the following points underneath or under the translation defined by xy goes to x plus 7 and y minus 2. Okay, so the regular letters without the tick mark are what we start with. So part A, that 0, 0, that's what we start with. Then we're going to apply this transformation that says we're going to plus 7 to that x, so we get 7, and we minus 2 from that y. So 0 plus 7 is 7. 0 minus 2 is negative 2. Hey, and that's the image, or the P1, or P prime. Okay, now let's go to part B. The same thing. We're going to add 7 to the x's, and we're going to minus 2 from the y's. Okay, let's see what that gives me. That gives me something new, or Q prime, and the x value is now negative 5 plus 7, 2, and the y value is now 4 minus 2, 2. Hey, that's your image. Okay, let's go to C. C says negative 7 and negative 1. Well, first we're going to add 7 to the x's, and we're going to minus 2 from the y's. Let's see what that gives me. That gives me r prime, because it's my new point. And for the x's, when I add 7, I get a big fat 0. And when I subtract 2 from negative 1, I get negative 3. Okay, so these are the 3 new points that we get after you've added 7 to the x and minus 2 from the y. Okay, so what they gave us to start with, P, Q, R, is what we started with. This P prime, Q prime, R prime is the aftermath. Alright, let's look at this next example. It says the image, well, We got to figure out whether that's what we start with or we end with. So let's go over here. It says the image is what we end with. Oh no. Okay, so this is the end result. Okay, and it's the end result of, what does it say the translation is? Adding 2 to the x's and minusing 2 from the y's. So this picture is the end result. It's kind of like these answers from part A, B, and C, and we're trying to go backwards and figure out what we started with. Okay, well, let's see here. The question is, where was this little rectangle at before we added 2 and subtracted 2 from the x's and y's? Well, let's go ahead and find what these points are. Okay, so this is the end result, and then we'll talk about where we started. Okay, so the end result is this far left point is negative 3, and it's no up or down, so 0. Then there's a 0, 0. Then there's a to the right 2, down 2, negative 2. Then there's a, I missed this bottom left one. Left 1, down 2. So negative 1, negative 2. Okay, so the question is, we want to know where we started. So what numbers did I have over here on the left that when I add 2 to the x's, and for the y's, we minus 2, we get these new points. So let's see here. What plus 2 gives you negative 3? So what plus 2 gives you negative 3? Or another way to think of this is this negative 3 minus 2. Because if you subtract the 2 over, and negative 3 minus 2 is negative 5. So let's see. If I write down a negative 5, when I add 2, I should get this negative 3. And I do. So let me write down that negative 5. Okay, let's keep going. What plus 2 will give you this x value of 0? Let's do all the x's first, then we'll go back and do the y's. Okay, so what plus 2 gives you 0? And the answer is negative 2. Okay, now let's look at this third one. We're doing all the x's first. What plus 2, because we have to add 2 to the x's, it says it in the parentheses. What plus 2 gives you 2? And the answer is 0. Okay, lastly, we have what plus 2 gives you negative 1? Well, negative 3. Okay, now let's look at the y's. I want to know what I could put in this blank that when I minus 2, I get 0. Well, 2. Let's see. That y value minus this 2 they're telling us gives us a 0. Yay! Okay, keep going. What minus 2 gives me this y value of a 0? And the answer is 2 again. Okay, let's keep going. What minus 2 gives you this negative 2 in the y spot? 0 minus 2. And lastly, what in this blank spot minus 2 gives you negative 2? So blank minus 2 equals negative 2. What's this blank? And it should be 0. Okay, so it says find the original parallelogram. My OG parallelogram, what I started with, should be left 5, up 2, left 2, up 2. I think I drew that wrong. Left 5 is over here. Okay, left 2, up 2, then 0, 0, and -3. So if I were to draw those points that we just found, then that parallelogram, that's where we start. And then check yourself. If I start with this pink parallelogram and I add 2, that means it gets shifted to the right. And then if I subtract 2 from the y's, it gets moved down to this blue guy. So we did it right. Yay! That one was tricky because we went backwards. All right, let's look at this sucker. It says, find the image of the quadrilateral to the right in a 270 degrees counterclockwise rotation about D. What the heck? Okay, well, let me just draw this picture. Okay. Okay, it says counterclockwise about this point D. Okay, and we want to go 270, but let's go slow. So this is what we start with. Okay, and if I take this picture and turn it counterclockwise just 90 degrees, this DC that's along the bottom, left to right, is now up and down. Okay, so I take this picture and I spin it around. I hold the point D down and then I spin the picture around. It should like this. It should look like this. Longer on the top, shorter on the bottom. Okay, so we just turned it around 90 degrees because that DC that was side to side is now up and down. Okay, so we turned it 90 degrees. Now we're going to turn it another 90 degrees. This CD that was up and down is now going to be side to side at the top. I'm trying to break it back long. CD, CB. I think I'm okay. I just feel weird. Okay. So we turned it another 90 degrees, which makes 180 degrees. So you hold down that D point and you turn your paper 90 degrees. Hey, there we go. Then we turn our paper another 90 degrees. Then we turn our paper another 90 degrees. So 90 degrees means a quarter turn. Okay, so we had DC along the bottom. We turned it 90 and it went up and down. We turned it 90 again and it went left to right, that DC. Then we turn it again and that DC is now on the left. Yeah. Okay, so when it says turn counterclockwise, it means to the right. Okay. When it says about the letter D, that means hold the letter D down with your finger. Okay. Now turn our paper 1/4 of a turn, or this DC is going to go from side to side to straight up and down. Okay, so that was 90 degrees. Keep your finger on that D. Now this DC is going to change from going straight up and down to side. Okay, then one more 90 degree. This DC, that's side to side, is going to go up and down. And we're going to end up with this picture, or what I drew right here. Okay, so counterclockwise means up and around to the left. Clockwise means around to the right. Alright, let's look at this next sucker. It says the image of noon is still noon, and the image of H is still H after a certain half turn. Let's remember that image means what we end with. So this is saying the end result of noon is still noon after a half turn, and the H is still H after a half turn. Now it says choose what other words will have the same thing. Okay, well, let's see here. That means I have, let's see, noon. All right. If I spin this around 180 degrees, as in hold down that N and spin it around, whoa, not a full circle, just half a circle, I still get noon. So if I take this noon and flip it around, I still have noon. Same thing for H. If I have the letter H, hold it at the bottom left and spin it 180. Hey, it still looks like an H. So the question is, what other letters do that? Or what other words do that? Well, let's check. Here's M-O-W. Hold it on the bottom left and turn it 180 degrees, or a half turn. Oh, hey, it's still Mo. Okay. Let's try radar, because those are the same forwards and backwards. But if I rotate it, hold it down on the bottom left and rotate it 180. That does not make the word, I can't even read that word. It's not the correct order. So radar does nothing. Okay, let's look at the letter R. And let's go ahead and do the letter Z and the letter D. I'm just trying to do 3 of them at once. Okay, so let's flip this. I'm going to hold down that bottom left, and I'm going to turn it 180 degrees. That means 2 90s, or half a turn. So let's turn it half a turn. Okay, out of these letters, which one can you still read as if it says D? Not this one, it's upside down. Z. Hey, that's totally a Z. Yeah. R, it's upside down. So, no R. Definitely a Z. D was no bueno either. Okay, now let's try SIS. We're going to hold it down on the left, and we're going to spin it around a half turn. So let's spin. Oh, look, it still says SIS. So that one has the same half turn symmetry. Woohoo! All right, let's keep going. The next sucker is kind of odd. This one's a real long problem, but the good news is I put all your answers up here. Okay, it says describe the turn symmetries, if any. Okay, well, it means when can you turn it and get the exact same picture back. Okay, so here's my square. Yeah. And let's just turn it, if I turn it 180, let's see if I get the same thing. Oh, it's the same exact picture. Okay, so I can definitely turn it 180. Let's see if I can just turn it half of that, or 90, and get the same picture. So I hold down this bottom left, and let's remember this is a square. I turn it 90 degrees, and hey, I have the same picture. So a square can be turned every 90 degrees, and it'll look like the same picture. The only thing is, you have to choose about the point of intersections of the diagonals. Because if I hold down a point on the left and turn it 90 degrees, my square is not over here anymore. So it's saying, when is there exact symmetry? Well, if I have a square, this isn't quite a square. Okay, there we go. That's better. If I have a square and I hold down that left corner and turn it around, yeah, I get the same picture, but instead of the picture being over here on the right, it's on the left now. So it actually moved. Okay, where can you hold the square down and the square will not move from this area? If you hold that square right in the middle of the intersection of diagonals and you turn it 90, we get the exact same square in the exact same spot. You turn it another 90, I get the exact same square in the exact same spot. Whereas if I hold this bottom left-hand corner and turn the square, oh my gosh, the square hops over here on the left. We don't want that. So it's asking, where can you hold it down and spin it and it get the exact same thing? Well, we can hold it down in the middle and spin it 90, 180, another 90, and another 180 to get the exact same picture in the exact same spot. So we're going to say it turned every 90 degrees at the intersection of the diagonals. That means right up in the middle. Okay, for part B, same thing. We're going to hold it in the middle, or the intersection of, this time, the perpendicular bisector of the sides. And the question is, how many degrees can I turn this and it'll come out to be the exact same thing? Well, the way we figured that out is kind of how we did the square. Secretly, a square has 360 degrees. And if you divide it by how many sides there are, 4, that tells us the turn we need to take to get the exact same picture back. So same thing here on part B. A pentagon has 360 degrees. And you're going to divide it by how many sides there are. 1, 2, 3, 4, 5. 5. And that gives you 72 degrees. So if I have this pentagon, the only way I'm going to get the exact same pentagon back is if I hold it in the middle and turn it 72 degrees. Not quite 90 degrees, because I don't get the exact same picture in the exact same spot, but just 72 degrees. Okay, and again, we got that by 360 divided by the number of sides. And you're going to choose the intersection, like part B up here. Okay, a regular n-gon. That means, what if my thing has 20 sides? What if my picture has 80 sides? What would be the degrees at which we turn to get the exact same picture back? Well, we do the same thing. 360 divided by how many sides there are, and an n-gon means there's n sides. If I called it a 5-gon, like a pentagon, that penta means the 5. N-gon means there's n amount of sides, or there's not a number of sides that we know. It's just the letter N. Okay, so this sucker is going to turn at 360 divided by n. And again, you have to use that answer choice that says intersection. And if you're wondering if this is going to be on the test, it's not. Don't worry. All right. Then part D says, when can you turn a circle and get the exact same circle back? Well, that's a trick. If I hold this circle right in the center and I turn it 10 degrees, I got that exact same picture. If I turn it 90 degrees, I got the exact same circle. No matter how many degrees I turn, I'm going to get the exact same circle. Yeah. Any angle. So that's why it says rotation about the center by any turn angle. So this circle, if you spin it around at any angle, it's still going to get the exact same circle back. Alright, let's look at this triangle. Let's see, if I hold it in the middle, the question is, will I ever get back the same picture? In the exact same spot. Well, let's see. Okay, here's my triangle. I'm going to hold it in the center. And first, let's just rotate it 90, half a turn. So, bam. Does this picture on my note card look like the one on the paper? No. Darn. Okay, let's hold the center again, and let's turn another 90 degrees. Okay. Does this picture on my note card look like the one on the paper? Yeah, but it's not in the exact same spot, exact same place, exact same placement. Okay, if I hold it down and I turn it again, I don't get the same picture. The only time I can turn it and get the exact same picture in the exact same space is one full circle. Or no half turns. So it says describe the turn symmetries. We'd have to have a 360 degree turn. Or that's called the identity, which means you get back the exact same picture after 360 degrees. That could also be for a circle, but for a circle, no matter how many degrees I spin this, rotate it, it's still going to be the exact same circle in the exact same spot. Alright, let's look at this M right here. It says find the pre-image. Well, we got to figure out what that is. Pre-image. It's what we start with. Oh no. So we want to know the starting point, whose image is given in the following grid. What does image mean? Image is the end result. So this question is saying that the end result of the translation is the letter M, but we want to draw where it starts. And then it says, in the following grid, after undergoing the translation x to x prime. Okay, down here, x and x prime. X, without the little tick marks in the air, that's the OG. That's what we start with. Yeah. Okay. Then the thing with the little tick mark, x prime, you can barely see it, but that x prime is what we end with. It's the image, or what we end with. Okay, so let's see. How did we get from where we started to where we ended? it? It looked like we went up and left. Yeah. From the bottom to the top, we went up one, left one. Yeah. Okay. But let's see what this M is. Is this M the start or the end? This M is the image or the end. Okay, so it's saying, what did we have before the end result? Yeah. So it's like we're going bass-ackwards. To get from the end, we have to go to the right one, down one. To go from the x prime to just the regular x. Okay, so that means on this M, we're going to go right one, down one. Right one, down one. Every point that they have drawn, you're going to move it right one, down one. Every point that they have drawn, you're going to move it right one, down one. Right one, down one. Right one, down one. And then connect your letters. You should still have that letter M. Hey, answer, I think it looks like A. Yeah, A. So this was tricky because whose image is given means that that picture on the paper is the aftermath, and we want to know where it started. Okay, then that thing with the tick mark, the X and the tick mark, that's the aftermath, and we wanted to know where it started. So to get from the aftermath, or where we ended, to where we started, we had to go to the right one and then down one. Yeah. So on our picture of an M, to get from where we ended to where we started, we're going to go right one, down one. Okay, let's keep going. The next thing that we're going to cover is tessellations. Tessellation is what you see like in your kitchen or your bathroom. Probably. You probably have a tessellation on your kitchen floor or your bathroom. It looks like tiling that fits together. So like this hexagon thing, sometimes you see that in bathrooms with like black and white tiling. You've seen it. It's cute. It's vintage. Okay, or you could have tiling of triangles. That's kind of odd. Or this rectangles thing. This kind of looks like some backsplash in your kitchen. Yeah. And that's exactly what a tessellation is. It's where you can take shapes and fit them together perfectly with no extra space inside. So these two bottoms pictures of circles and ovals or ellipses, they're no bueno because there's space inside. Yeah, and that space inside does not look like a circle. Okay, so the only way things can tessellate is if they fit together perfectly. Okay, let's look, and no overlap. No overlap. For example, if I'm looking at this backsplash, in my kitchen at home, I do not want a green rectangle of green tile and then a piece of blue tile on top of it. We don't want that. We want them to fit right beside each other. Our tiles do not need to overlap. That would look horrible on our kitchen floor or our kitchen backsplash. Okay, let's look at this. It says on dot paper, use the pentomino. Whatever that is, I'm guessing it's this. It looks like 5 little boxes. Okay, so use the pentomino on the right to make a tessellation of the plane. There may be more than one correct tessellation. Okay, so that means we have to look at these pictures and see which one has this letter L fitted up right next to another letter L. No overlap. So if you look at B, we could take this L tile and we could tessellate it like B is. See how they fit right into each other perfectly? That's perfect. Yeah. If you look at C, look at those L's. It's like we took a regular L and then we flipped it upside down and put it on top of each other. Yeah. And then we just kept doing that over and over and over. Well, that's a tessellation. But look at A. You can barely tell. It's a bad picture, but you see how that pink is overlapped the green? What is happening here? This does not look like this L. Like the green and the pink. I said pick. The green and the pink are not the letter L. They're overlapping on each other, so A's out. So the question was, which one is a possible tessellation? Well, we could have B or C. As long as they fit together perfectly and don't overlap, we can do it. Okay, let's see. This next one, this triangle, it says identify a tessellation on the plane. Well, let's use that same theory of no overlap. We don't want our tiles all on top of each other when we walk through our bathroom. We're going to fall over and stub our toe. So let's see here. Which of these do not overlap? This first picture, it looks like that pink is on top of the blue triangle, so that's not cool. He's overlapping. This B, I can't even see all of the blue triangle, so it's overlapping. This D is not even a triangle, that pink piece. Yeah. So the only way we could fit these triangles together is to just put them side by side. Yeah. And then maybe we could even tessellate it like this and have triangles on the other side. But to start out with, to tessellate, you can not have any overlap. And A, B, and D, all the triangles were on top of each other. And that means you're going to stub your toe when you walk on that tile. All right, that's it. All right.